Hello and a very warm welcome to our bauma talk. bauma, in cooperation with VDMA, is phasing out 5 bauma talks as appetizers for the large key topics on the live exhibition in October. My name is Darius Sostov and I am working for the construction division in VDMA. Today, I will invite you to a very interesting journey to a digitization and digital construction site. BIM, fleet management, electronical delivery, nodes and so on are only some parts of a digital construction site. But it is much more. This mapping requires a large amount of data which each individual machine provides. Today, construction machine data differ in their appearance and in their content. A suitable example is the simple question: in which condition, in which status a machine is if it is switched on? Every machine manufacturer has his own interpretation. But unfortunately, they are not comparable. One who can tell us about having the wrong data is Michael Tonke. He is responsible for digitization at Weiss and Freytag, a large construction company. And in addition, he's a member of the board of the main association of the German construction industry, HDB, Hauptverband der deutschen Bauindustrie. Welcome, Michael. We are happy to have you here today, and the floor is yours.
Thank you. Hello and welcome. Thank you for the opportunity to attend this bauma talk. My name is Michael Tonke and I'm the head of the mechanical department of Weiss and Freytag Civil Engineering. And as Dario said, I'm representing the main association of the German construction industry, Hauptverband der deutschen Bauindustrie. I was quite impressed with the first 2 bauma talks on development of autonomous systems such as cobots. And my task today is to give you a short overview about digitalization and sustainability of construction machinery from a user's perspective. How looks it like today on our construction sites and infrastructure projects? To be honest, we are just at the beginning of utilizing the resources offered by digitalization. Their main focus are on quality assurance, optimization and increasing of the effectivity of the construction process where machinery is used. Examples are automatic control of verticality of bore piles, load check of cranes and remote maintenance. Today there is no problem to get machine and process data. The challenges are quality, further processing and use of the data. What is the status quo? In an equipment fleet of a construction company today, we use many different devices, manufacturers, and systems, up to 200 in a large equipment fleet. We have to deal with a lack of standards and inconsistent, incompatible interfaces, what means high costs and handling of many different systems. The need for standardization of construction machinery has forced us to come into a dialogue with the manufacturers and led us to be an active founding member in MIG 4.0, Machines in Constructions at bauma 2019, in order to find a platform and connecting point between the machine manufacturer and us as users. Goal of MIG 4.0 is a standardized, cross-manufactured, machine type independent and legally compliant communication around the construction process, machinery and its processes in general. Important for us as customers is to have the guarantee of data sovereignty. That means protection of data, know-how and trade secrets. Therefore, our demand is a quality assurance system, for example, a quality label by an independent test center, which could certainly be a purchase criterion for us customers. On the way to today's main goal of stopping climate change, we too have to try to reach zero emission. New drive technologies offer the possibility of low emission construction, but the share of construction materials in the total emissions of a construction site, like concrete, steel, bitumen, is often larger than 90%. This is where the main savings potential lies. But of course, we want to make our contribution and do our homework. Challenges for us as mechanical departments are high acquisition costs. The economic efficiency is often not yet given in the moment. Increasing requirements for operation, maintenance, and service. Technological limits, for example, when we think of volume and weight of batteries for large machinery. The infrastructure is often not yet available when we think about power grid, provision of sufficient electrical power, and so on. Large mobile devices can easily run on diesel autonomously. Battery solutions inside cities are fine, but outside it is problematic or impossible because there is no suitable infrastructure. Different drive types on a construction site, such as diesel, electric, hydrogen, and fuel cells, lead to more individual processes, higher costs, and more complexity. But not to be too negative, there are, of course, initial results and sustainable solutions. Today, we use photovoltaic systems on our mobile containers and even mobile battery systems for the operation of small electric machines, what at the end lead to the elimination of diesel generators. Today, an intelligent construction machine means the support of semi or fully automatic functions for more safety, for process monitoring, or for data acquisition. At least for the moment, it's not yet common to have full automated machines on our job sites. There is still a high potential to increase safety, efficiency, and production if we think of wear reduction, precise use of materials, and increased measurement accuracy for those works. This use of these systems lead to a relief from tiring, monotonous work steps, in the end to protect our personnel resources to the increase of health and safety. This brings us to another important point, human resources. In the end, in an industry that still seems to be noisy, dangerous, and dirty, digitalization increases the attractiveness of a job in the construction industry. So we see an image boost and improvement for us, and of course a help in recruiting key personnel. Thank you.
Michael, thank you very much for this very good overview from the point of the construction industry. Construction companies need a lot of data for digital construction sites. And I want to ask today my expert, my guest, Michael Tonke from Weiß & Freytag, what's behind this? The first question to you, Michael. Construction companies are supposed to build something. Why do the construction companies suddenly need such a lot of data for a digital construction site, and why a digital construction site?
Only with an analysis of our processes we are able to automate these or can increase the effectivity of the construction process. Often in these days, our clients demand even data, for example, to check the quality or to prove that technical criteria were reached. Coming to safety, to check the ground pressure for the stability of a large machine of more than 100 tons is even a point. Another one is, only with data we are able to reduce manpower when we think about maintenance or remote control of many single machines. For example, many pumps for water management of a large special foundation site or a tunnel project. We all have to deal with the lack of key personnel today, and even experts. And to be honest, I'm sure we will not get more of them in the future.
No. Okay, thank you. The question is, can this issue not be dealt with by each individual construction company on its own, for example? And is this issue can be then by its own used as a kind of competitive advantage for a construction company?
No, I do not think so. It is not possible to solve the challenges as a single company. We have first to bundle resources and knowledge, and even as an association, we have to take responsibility for our small companies. Otherwise, we would have to talk to many manufacturers, and for them it would mean all or many customers show up with the same open questions.
Yeah, that's clear. Yeah. You have mentioned MIG 4.0, the MIG 4.0 approach. Can the MIG 4.0 approach solve your requirements of the customer's company, of the construction companies, and also shape them in the future for the future processes in your sense?
If we can solve this, of course, I do not know, but it will definitely help. Only together and in interaction between the manufacturer and user of construction machines, we are able to solve all open issues. Otherwise, we would have to talk to many different manufacturers and would end where we are today, many different systems, incompatible systems at the end and interfaces. Also, we often work, especially if we think about large infrastructure projects, in joint ventures where a bunch of construction companies is involved. And honestly, issues like data rights, legal compliance, and so on, we for sure can only solve together.
Thank you very much. One last question and one quick answer. Digitalization, automation, human resources, digitization can help. But the question, how can digitization help to come to zero emission?
Points like fleet management, reducing of fuel consumption, etc., work only by getting data, compare them, and derive consequences. Control of machines, for example, to reduce permanent power level, starts with measuring, data collection, and use them to increase effectivity of single machine processes with the final aim to increase energy efficiency and come at the end to zero emission.
That seems to be clear. Thank you very much for being here.
Thank you.
And thank you very much for being in the chat for further questions.
Thanks a lot. It was a pleasure.
Thank you. The digital construction site is possible. The prototype is existing. The most relevant researcher, Professor Weber, is with us today. He is the director of the Institute of Mechatronic Engineering at TU Dresden. He is an expert in research and a pioneer in digital construction site and the leader of the most relevant joint research project Bauen 4.0. I'm very happy to have you here today and will listen to your presentation. Professor Weber, the floor is yours.
Darius, thank you for your introduction. Big words. I hope I can fulfill this expectation. Last time we have talked about autonomous machines, and today I would like to give you more an insight in our digital construction side, in our concept, in our solutions. We have heard in a previous speech or in the previous presentation a perfect motivation from a construction industry to go into the digital construction sites and in the digitization of these processes. What I would like to add is here we are facing on our construction sites, what you can see here of the chart, mixed fleets. That means all the subcontractors are running different machines on different or fragmented technology levels. And also the construction industry itself, they have their own machines from time to time and also rental machines. So and all these different issues has to connect it together, and this is a huge challenge. The second issue is a lack of mobile coverage. That means on our construction site we have very often no connection to the internet. So also here we have to find a solution. Let's have a look to our concept, to our architecture, in which way we would like to solve or to address these issues. You see here our concept, and the heart of it is a local network what we would like to implement on a construction site combined with a site control system. This local network will realize the connection to all assets on a construction site, that means to all machines, which have itself a connectivity module so that the machines are able to exchange data from machine to machine or from the machine to the system, to the centralized system, to the construction site system. On this centralized construction server, we will have a couple of different software modules implemented, for example, to simulate in real time the construction process. Also to have apps running to tracing and tracking all the materials, what we have, or some other devices what we have on the construction site, or to store and to analyze our machine data. You see also on the chart an interface, a customer user interface, for example, from the management of the construction site, to act with the information, to control and to react in real time on all the happened situations or scenario. Let's go further a little bit more into the flow of the information and data. You see here the hierarchical levels on networks from top to down or from top to bottom. The offsite, the public network, from what you could imagine comes the overall project, has to be realized. Then you see the on-site private campus network, in which we have installed this connection or connectivity server and also running the construction site control system. And on the machine side, the already mentioned connectivity module, when I remember to our previous presentation. What I would like to highlight is the data flow. That means we start with a load order data. The task manager is defining mainly daily wise or something like this. The excavator job, for example, convert that into a job, local coordinates, and then generate on a land XML file what the machine has to be done, has to be fulfilled. And then via our OPC UA middleware, we are transferring this information, this data to the machines, and the connectivity module runs a process on a machine locally to calculating, for example, for a certain job, the slicing of a digging which has to be run, and then we can also connect this with automation functions. After the job is finished, sensors like cameras acquiring or recording the fulfilled data, let's say the as-built data, and send it back in the vertical direction back to the construction site system or into the offsite in the public network. I have already mentioned sometimes the OPC UA as a middleware. We are developing a special model for construction machinery, and to be honest, not to invent the wheel on a second time. We are also, let's say, have synergies to already existing data from telematics, from kinematics on robots, from topographical data and so on. And we add this with a specification of construction machines. We are collaborating very closely with working group MIG 4.0, what you are heavily involved in, to achieve a certain standardization and a certain common sense and understanding. Let's come to the end with a short outlook. I would like to inform or present here a Construction Future Lab. This is a just founded non-profit company, if you like. And this Construction Future Lab would close the gap between the research and the market readiness to be open for all interested industry partners and all interested research partners to be a neutral partner for other further developments to achieve the readiness and market readiness for digital construction sites and processes. So far, my presentation for today. Thank you very much.
Yes, thank you very much, Professor Weber. From my point of view, the prototype is existing.
Yes, the prototype is existing.
Thank you very much. The prototype of a construction site, of a digital construction site, is existing. The scenario of a digital construction site is mostly unclear. Is it like an app? Is it like a software? Is it like a final product? These are the questions which I will discuss with my guest, Professor Weber from TU Dresden. Professor Weber, what about a digital construction site? Is it an app? Is it a software? Is it a kind of a final product which a construction company can use at the end?
It's a complex question. I would answer in a way that I would highlight it's a merger of a specific hardware and software. As I mentioned already in my presentation, we have a local network in form of hardware to be able to have a connection to all the machine, to all the assets on the construction site, and with the server implemented software modules realizing the simulation of processes, apps for tracking and tracing, apps for, let's say, watching, observing the quality, the time, the cost of the construction site. And so this is for me the overall digital construction site. That means the hard and software we need to have all the data available, what we need to follow the processes.
Yes, okay. You need a server, you need processes, you need apps. To digitize a construction site, there are some requirements, are absolutely important. The question is, who and which construction company can fulfill these requirements at the end of the day? Only the large one, or also some small and medium ones?
I would say all the construction industry has to fulfill, has to be involved. For sure, the big ones as a major contractor, but also the subcontractors has to be integrated into the digital processes. And if they are not able to do this, I could imagine they are out of the business at the end. And so there is a certain push or pressure behind to get readiness also for the smaller companies in this technology, so that they can involve and work together in this heterogeneous, let's say, groups on contractors and on a site.
Okay, so that the solution is only together.
Only together.
Only together. You mentioned Construction Future Lab. It's a totally new approach. And my question is, what are the next ideas, projects and regardings on this topic? Surely not all questions are answered in Bauen 4.0. What about the Construction Future Lab? Is the Construction Future Lab later on able to answer the open questions?
I hope so. In the research project, we can also only, let's say, develop certain concepts, architectures. We need a certain phase to get these concepts market ready for application. And also, I could imagine that we have to bring together the different players on different technology levels to check if they are compatible with their technologies, with their machines, with their software systems and connectivities. We will also go into, let's say, construction methodology like 3D printing of concrete, for example. Machine technologies will one of the major topics. Everything what we need around the construction site, the digitization, the virtualization, and so on. A huge area of activities will wait and running. Yeah.
Okay, so that the first prototype of a digital construction site is not the end, it's the first step.
Yes.
Thank you very much for being here with us, and also thank you for being available in our chat. Thank you, Professor Weber. The digital construction site is nothing without common understanding of data. Last weeks, months and years, of course, Alexander Moser and I talked much about the requirements of a common language, of a common data understanding. He is experienced in different machine data, and he is leading the role of the machine digitization at Leonhard Weiss, a construction company and a large machine user. Hello, Alexander. We're absolutely happy to have you here. And you bring us a presentation why a common digital language and a common data understanding is so important. The floor is yours.
Thank you, Mr. Solsdorf, for the kind introduction. I'm glad and happy to be here and to present the perspective of a construction company in terms of digital machine data. First, I'd like to start for a better understanding with a short background to this topic. Modern construction machines come or are equipped with the telematics from the manufacturer. The telematic units deliver digital machine data, for example, the position or the operating hour to each OEM cloud. To get access to the machine data, it is possible to use a web platform, or you can use a web interface API, which, for example, is defined in the ISO 15143-3. Since the construction companies have usually machines from many different and not only from one manufacturer, it is not practical to work with several different platforms or web portals. Therefore, it's to prefer to connect the data over an API to the IT infrastructure of the construction company. To increase our efficiency, the machine data are more and more important for our processes. For example, for predictive maintenance, transport and logistics, and also for processes on the construction sites. A good example is the current topic, the CO2 emissions, where the telematics can deliver important information to the fuel consumption of each machine on the site. Also, the position of the machine has a high potential to save search times in our processes. Another important parameter are the operating hours, which are needed for a lot of processes like maintenance and billing matters. At the next, I will come to the challenges. However, there are some challenges that make working with the machine's data difficult for the construction companies. First, each web portal and the API definition are different. This makes it very complex to get use of the data for the whole fleet. Second, the parameters are individually defined by the manufacturers. Therefore, it's not possible to compare the data from one OEM to the other. It could be that the idle hours, for example, of manufacturer A is not the same like the idle hour of manufacturer B, because there are no standard for the calculation of this value. In addition, the ISO 15143-3 or AMP20 are only for earth-moving and road construction machinery. However, we need a clear definition for all machine types. For example, cranes, machine in concrete technology, pilling and drilling machinery, and so on. Further, there is a high administrative work and a complex machine and data management. An example of this is the process of adding new machines to the account of the construction company, as well as the cancelling of the machines. Usually, I would assume this is a short and easy, fast process, but this can result in a very time-consuming step. Finally, the whole topic of data protection and data privacy issues, and the associated paperwork, which could be very frustrating. This requires a lot of effort before the data can be used in our company. Finally, I will come to the goals. In order to make the topic to a success for everyone involved in this topic, it is from most importance to work on it together. And this is only possible in associations like Machines in Construction 4.0. The following goals can only be achieved together with everyone involved, from the manufacturer and the service provider to the user. We need a common understanding and a clear standardized definition of the parameters. This means, for example, the operating hours of excavator A should be the same as the operating hour of excavator B from manufacturer B. This includes also the intervals and the accuracies of the machine parameters. Currently, it could be that we get from machine type A the machine data every 50 minutes from the next machine type every hour, and from some manufacturer we get the data or once a day, and this is absolutely not usable for us. All machine types in the fleet must be considered. So the ISO and the IMP looks only to road construction and earth moving machinery, and we need also all other machines. We have construction sites in rail projects. We have construction sites in rail projects. We have civil engineering projects, and we have road construction projects. So we have, we need all machines in this, in this case. The data provision and the connection have to be standardized. This is a very important point for the connection of the machine data over an API to our IT solutions. In other case, we have a high effort to get use of the data. And finally, for the future, it's very important to consider all process and quality data of the machines. Today's machines have many assistance systems like crate control on the excavator or solutions for the documentation of compaction values on rollers. In the standardization of this process and quality data is a high potential to increase our efficiency and could be very helpful for our construction sites in the future. Thank you very much. I hope I can give you a short insight into this topic, and I'm looking forward to your questions, Mr. Sostav.
Thank you very much for this high impressive presentation. And it seems to me that we have to do a lot of work in the future.
Yes.
Thank you very much. Much data and common understanding of data is a requirement from the construction companies. I want to ask my guest, Alexander Moser from Leonhard Weiss, why it is so. And also the question, if it is so, that you need a common understanding, why can't this be done by a large, one single company for all?
We have a lot of projects in rail, we have civil engineering, we have road construction projects, and a large number of machines and several machine types. So I cannot imagine that one manufacturer can build all our machines and can deliver for all special uses on the construction sites, the machinery. So I think it's only possible when all manufacturers work together in associations like MIG 4.0 together.
Okay. Yeah, in this case, for me, it's coming up the question, if all the contents of the data are uniform and unique, won't the machines and the possible processes which the machines is absolutely the same? Is this not a disadvantage for the machine manufacturers?
Oh, I don't think so. We talk here only about the digital data from the machines. So in the first step, we talk about machine status data, for example, operating hours, idle hours, and position. So I think the parameters should be the same in this case. And I think all manufacturer has an advantage when they work together and have a standard. And so it's not necessary to have single solutions for each customer or user of the machinery.
Okay. And if you're sitting together, on the one side the machine manufacturer, there are competitors in their field. On the other side, the construction companies, they are also competitors in their field. How does it work?
Oh, I'm active in several clusters from MIG 4.0, and it's a very, very good work together. So everybody has the same goal to get a standard, and each I tell it under another way. Thank you. If the manufacturer or the service provider or the customer, when we have the same understanding of the data, so I think this is the advantage for we have an advantage for everyone.
Yeah, it had nothing to do with the work of the machine, only with the data which has to be exchanged.
Yes.
At this point, can you give us a short outlook? Do you have any first results from this discussion together, from these clusters you mentioned, MIG 4.0? And it's seemingly a absolutely unique approach in this scale. Or does other associations or other groups do the same thing?
No, I think this is really unique in MIG 4.0, and we have very good results. All clusters, which is for different machine categories, have a common understanding for the machine state restarter, which is defined in the ISO 15143-3. And I think this is a really success which is given on this association.
So you bring the ISO 15143 in the data format to a one common understanding and a one common interpretation.
Yes.
A very good approach. Thank you very much for being here, and thank you also that you would be able now to sit in our chat and able to answer possible questions. Thank you very much, Alexander.
Thank you very much.
Changing attachments on construction machines however you want is impossible because of data interfaces. All the relevant manufacturers must open their mind and talk to each other. One who is bringing them together is Katharina Schick. She's a project engineer at Liebherr and responsible for digitization of attachments. I'm happy to have you here today, Katharina. Very warm welcome. And you will explain us something about attachments, machines, and what's happened.
Yes.
The floor is yours.
Thank you, Mr. Sostorff, for the kind words of introduction. So as he said, I'm here today to talk about the MIG 4.0 bus. And I want to start my presentation by maybe asking a provocative question. I want you to think about, what is this excavator doing? What work are they doing? And you don't really know. They might be digging a hole, they might be spreading the gravel around, or they might be compacting. And the reason you don't know it is because you can't see what tool is he currently using. So the tools that are used by excavators and other construction machines are really central parts of the construction site and are central for doing the work that needs to be done. And we have today a wide range of specialized tools that do their work very efficiently, but with that comes a problem that you have to talk about interfaces. And for the hydraulic and mechanic interfaces, we have today good solutions in the market, but the tools that we are using are getting smarter and smarter each year, and there are new functions that make everything more efficient. But with that, you have to talk also about data interfaces, because for smarter tools, there has to be smarter communication. And there today, we are coming up blank. There's no good solution available in the market. And also, if you think about what I said earlier, if you are sitting in the back office and want to monitor what is going on the construction site, you can't really know because you don't know what tools are being used, at least what I would say. So from MIG 4.0, we have this vision that we want to solve this problem. And so we set ourselves a goal to develop an open data interface for the communication between attachment and machines that is independent of all manufacturers. And this interface we want to call the MIG 4.0 bus. And if I say we, I mean the MIG 4.0 contributors. We are currently 24 companies working on the standard together. And from the machine manufacturer side, it's us at Liebherr, but also Volvo and Wacker Neuson. And then we have a big group of attachment manufacturers that are also contributing. And of course, and I think also most importantly, we have a lot of users in the group that are giving their input because they are the ones that will have to work with the standard when it's done. So when we think about data that has to be transmitted, our approach was that we think about the customer use cases that should be addressed with this interface. And we took this and then thought about, okay, what data do we have to have communicated from A to B to make these use cases possible? And we took this data and then put it into a CAN interface that is based on the SAE J1939 standard. If someone is familiar with agriculture, they have the ISOBUS standard, and we had a similar approach here. The use cases that we want to address are, for example, the tool identification, that when the tool is coupled to the excavator, you can transmit the basic data, such as what kind of tool is it, what manufacturer is it, and then also we want to transmit the necessary data to make machine settings for safe tool operation. For example, hydraulic settings or geometry data. One other big point of the protocol is tool control commands. So to send the commands from the excavator to the tool, such as tilt or rotate, and also operational data, such as sensor data. And this is the theoretical approach that we took, and I want to show you now a short video of our first test that we had this April. You can see in the video that there is a tilt rotator moving on the excavator in our test setup at Liebherr. And all the movements that you see are triggered by the MIG 4.0 communication via our MIG 4.0 bus. So there you see the protocol already in action. The architecture that we used for this is that we basically took a standard excavator, as you can buy it today, and the only changes that we did was we gave it a software update and one CAN line that connects the control unit from the excavator to the tool. And the tool control unit also has a software update, which makes it MIG ready. And with this setup, we were able to do the first tests of the protocol of the MIG 4.0 bus. And we didn't only test it with the tilt rotators. I have another video I want to show you. There you see a different tool. This is a compactor from the company MTS. They are also working in this project, and you can see here we just have to couple the tool. This does the mechanical and hydraulic connection, and my colleague Bernd Göbel from MTS, he just does the CAN bus connection. And if this is done, you can right away start working with the tool. There's no additional modifications needed to the excavator or the tool. So this is the future of MIG 4.0 that we are thinking about. So we are very happy with the tests we've done so far, and have great hopes for what's to come with the MIG 4.0 bus, because it offers a solution that is makes the use of attachments easier across manufacturers, and most of all for the user. And I also think that once we have this data transmitted and it's on the excavator, this opens up a lot of possibilities for future innovations. Especially if you think about digital construction sites and so on. And the last thing I want to say is I hope that you will visit us at bauma. There will be a MIG 4.0 stand in Lab 0, where we hopefully you can see the MIG 4.0 interface in action. These are my last words. Thank you for listening.
Yes, thank you very much, Katharina, for this quite impressive presentation. Digital becomes possible.
Yes.
The question, data exchange between attachments and construction machines becomes possible. This is what I want to discuss with Katharina Schick from Liebherr. Katharina, you're working on attachments, and you say in the future every attachment can change data with every excavator if it uses the MIG 4.0 bus. Sure?
Yes, that is correct. So we've been working on this project for I think about over 2 years now, and the main goal that we had is that we want to make it possible that there can be data exchange between the tools and the excavator. So we do not want to touch the hydraulic and mechanical interfaces, because there we have very good solutions on the market today, but if you talk about data exchange between the excavator and the tools, there you come up blank. So there's no good solution today, but we are working on the MIG 4.0 bus interface, and we've already done some tests, and I think we are on the best way.
Yeah, of course. The question is, isn't it bad for competition for the competition between the companies of attachments of excavator? If they have their own system, they won't sell their own system because it's good, better than others. Isn't this bad for that?
I would actually say the opposite. So we have a lot of machine manufacturers and also attachment manufacturers working on the MIG 4.0 interface. And today we have actually a lot of problems with this task of working with complex tools on the excavators because there is no standardized communication. So today you have to either do one-on-one talks between the manufacturers and find a solution just for one, or what's also often happening is that you have to do a lot of changes on the machine to make it possible to operate a smart tool. And so this, we don't like it as excavator manufacturers. The attachment manufacturers say, we have to do it, but we don't really want to. And for the users of the tools, it's also just a lot of work that has to be done before you can begin and do your actual work. So with the MIG 4.0 interface, if we have that, then you can focus on working. And also, if you remove this interface discussion, you can just buy the best tool for the job and start working right away. So I think that will actually improve competition.
Okay, sounds good. The question at this point is, which manufacturer can still jump on this train and can join this work? Or is it a closed job of a few of companies?
Yeah, so at the moment we are deep in the work of the first version of the protocol and are preparing for the presentation at bauma. So we said, okay, because everyone has added a lot of know-how to the interface, that we don't want to add any more manufacturers to the group before publication of the first version. But after that, we explicitly want other manufacturers to join, because only if this interface that we are developing spreads as far as possible, then it will be really a good solution. So we are hoping that many more manufacturers will join us after the first protocol is published.
Sounds good. It's an open system, an open approach.
Exactly, yeah.
Yeah, one final question. When will this system, this MIG 4.0 bus, available, and where will it be available?
So the goal that we have is that we want to present the interface so that everyone can see what we are talking about at the bauma, and that's where we are focusing our work right now. And the idea is that after we've shown the work, then we will have for bauma a prototype protocol basically. After that, we can do some finishing touches and want to publish the MIG 4.0 protocol interface after the bauma. And then I think I would give all contacts to you at the MIG 4.0 office at the VDMA, because they will be the ones handling the publication.
Thank you very much. It's an absolutely new approach. It's quite interesting.
Yes,
thank you very much.
I like working on it.
Yeah, thank you very much for being here. And I'm sure that you will receive a lot of questions in the chat.
Yes,
thank you very much, Katharina. The digital construction site becomes reality. Be a witness of understanding that will be the means of choice and the new approach only together. We must understand that only together we are able to solve the challenges of digitization. Visit us at bauma 22 and join us in looking forward to the first results of this new approach. Together and doing instead of talking. Thank you very much for the attention to our bauma talk, Digital Construction Site.